Hello, this is Mesos Oram, and welcome to S.F.M.L tutorials. Today, we'll be talking about circle collision. First, we'll need to set up a random number generator. So, standard, default random engine. Then we'll give that random engine a seed, random engine.seed, cast as int, then standard, chrono, steady clock, now, time since epoch, dot count. For the velocities and positions of our circles, we will need random floats, so standard, uniform real distribution, cast as a float, and random float. For the color of our circles, we will need a random integer, so standard, uniform int distribution, unsigned, int, random char, it will be called. Then we will say random char equals all of this, copy, paste there, between 0 and 255. Now we can scroll down, give us a lot of room, go down here. We need to know how many circles will be on screen, so const unsigned int num circles equals 10. We need to make an array of circles, so SF, circle shape, circles, with num circles amount. We also need an array of velocities, so SF, vector 2F, velocities, with an amount of num circles. Now we need a for loop to set up all of our circles and velocities, so for unsigned int I equals 0, I is less than num circles, plus plus I. We will first set up our circle's radius, so random float equals standard uniform real distribution float between 7.0 f and 24.0 f. Now we can say float radius equals random float random engine, and then set our circle's radius. Circles at I dot set radius. For our circle's position, we can copy this, paste it here, and then say it's between our radius and our float of our window size dot x minus 2.0 f multiplied by our radius. Now float x equals random float, random engine. Now for the y position, we can copy all of this, paste it here, change this and this to y. We need to set our circle's origin, circles, at I, dot set origin, as circles, at I, dot get geometric center. Now we can set our circle's position, circles, at I, dot set position, at x, comma y. Now for our circle's color, SF, color. Now we can say standard uint 8t_r equals random char with random engine. Now we can copy that, paste it twice, change that to a G and that to a B. Now we can say color equals SF, color, RGB. Now we can set our circle's color, circles, at I, dot set fill color. Now for our velocities, let's copy this, paste it down here, then change this to a -2 and this to a 2. Now let's scroll down a bit, give us room. Now we can say SF, vector 2F, velocity equals random float, random engine, copy that, paste it here. Now we have a random vector, we can say velocities at I equals velocity. To display all of our circles, we can say for unsigned int I equals 0, I is less than num circles plus plus I. Then window dot draw circles at I. Now we can save everything, then go into the debug menu and see all of our circles. Now we want to move our circles, so let's copy this, put it here, close it up, go there. Then we can say circles at I dot move at velocities at I. We'll want to keep our circles within the bounds of the screen, so we want to keep track of our circle's position, SF, vector 2F, position 0 equals circles at I dot get position. We also want to keep track of our circle's radius, so float radius 0 equals circles at I dot get radius. Now, if our position 0 dot x is less than our radius 0, or our position 0 dot x plus 2.0f multiplied by our radius 0 is greater than our float of our window size dot x, then we'll reverse our x velocities. Velocities at I dot x equals negative velocities at I dot x. And we do the exact same thing for the y's. Copy that, paste it down here, and change all of these to y's. Now let's scroll down, give us a lot of room. Go back up here. Testing out the code, this does not need to be multiplied by 2.0. Now we can open the debug menu and see that they all bounce off the walls. Now if we want the circles to collide with each other, we need another for loop. Copy that, paste it here, then change these to j's, and go down here. First off, we don't want the circle to collide with itself, so if I equals j, then just continue. We also need to keep track of this circle's position and radius, so SF, vector 2F, position 1 equals circles at j dot get position, as well as float radius 1 equals circles at j dot get radius. We need to know the difference in the positions of the circles, so SF vector 2F dx equals position 1 minus position 0. Now to get the Euclidean distance between the two circles, float distance equals the square root of dx dot x multiplied by dx dot x plus dx dot y multiplied by dx dot y. Now to check if our circles are touching, if our distance is less than or equal to our radius 0 plus our radius 1. We will need to know our distance squared, so float distance squared equals distance multiplied by distance. We will also need to know the difference in our velocities, SF vector 2F dv equals velocities at j minus our velocities at I. Now the first circle's velocity will be SF vector 2F new vel 0 equals velocities at I minus negative dv dot negative dx divided by our distance squared multiplied by our negative dx. And our second circle's velocity will be nearly the same. Copy that, paste that there, change that to a 1, that to a j, and take out these negatives. Now we can set the velocities at I to new velocity 0, and the velocities at j to new velocity 1. Now we can finally save, then enter the debug menu, and see that it works all well. Thank you for joining me today. If you did, then please like, comment, and subscribe, and have a great day.